Assalamualaikum and hi everyone. My name is Intan Nadhirah binti Ruslan from K2. So, what is the topic that we will be discussing today? It is ocean ion fertilization. For your information, I am referring the article given by Dr. which is Ocean Ion Fertilization Experiment, Past, Present and Future looking to Korean Ion Fertilization Experiment in the Southern Ocean Key Phase Project. So, first thing first, what is ocean ion fertilization? Ocean ion fertilization is the drawdown of atmospheric carbon dioxide by nutrient additions. As we know, there are a lot of nutrients such as iron, nitrogen and phosphorus. So for ocean ion fertilization, the main stimulus is iron. Why we added iron into the ocean? For your information, addition of nutrients used to stimulate the phytoplankton growth in the upper layers of ocean via biological pump. What is biological pump? Biological pump is the process of transforming dissolved inorganic carbon, DIC, into organic matter by phytoplankton and pumping the particulate form organic matter to intermediate deep waters called as carbon sequestration. Ocean ion fertilization can occur naturally and artificially. The example of natural ocean ion fertilization is dust inputs during last glacial maximum, while the example for artificial ocean ion fertilization is by injection of iron into the ocean. So let me look at the history of ocean ion fertilization. During the analysis of trapped air bubbles in the Antarctic ice cores, scientists found out that the atmospheric carbon dioxide level during last glacial maximum is lower than during pre-industrial time. Atmospheric level for LGM is 180 ppm, while for pre-industrial time is 280 ppm. Scientists started to find out what ways to reduce the atmospheric carbon dioxide level during that time. There are two methods proposed by the scientists, which are the enhancing biological carbon dioxide uptake using fertilizers and controlled solar radiation by aerosol injection to the atmosphere. So the most attractive method is ocean ion fertilization, because in the 1990s, John Martin proposed a iron hypothesis as he understood that iron can affect the ocean biological pump. Martin stated that during the last glacial maximum, there were a lot of dust inputs. As we know, dust input is the major sources for the iron that can help to relieve the iron limitation during that time. During LGM, the biological pump actually enhancing at the HNLC regions such as Southern Ocean. This is shown to us that the increases of dust increase the iron inputs, iron sources. So there is less limitation of iron and there are increasing of phytoplankton growth. Move to the main objective of ocean ion fertilization. Firstly, the objective of OIF is reduce atmospheric carbon dioxide through chemically engineered processes. Second, to induce phytoplankton blooms in high nutrient loss chlorophyll HNLC regions. Promotes phytoplankton growth by increasing intakes of micronutrients. There are four areas of ion fertilization, which are subtropical North Atlantic, subarctic North Pacific, equatorial Pacific, Southern Ocean. So, subtropical North Atlantic have low nutrient and low chlorophyll region, while subarctic North Pacific have strong longitudinal gradient in dust deposition, high in west, low in east. Equatorial Pacific have a high light intensity, which can stimulate the rapid phytoplankton growth. As we know, rapid phytoplankton growth can help in reduce the carbon dioxide in the biological pump. So Southern Ocean is the largest HNLC region in the world. This is the map of areas of ocean ion fertilization. As you can see, there are different colors used to indicate different phytoplankton at the area. For example, the orange color indicates diatoms, which have a high abundance at the area, while green is for picophytoplankton and pink is for zooplankton. So what is the relationship between iron and climate? From the result gained from iron experiment 1, iron will stimulate the increasing in the phytoplankton productivity. As we know, when the phytoplankton productivity increases, the absorption of inorganic carbon also increases. Therefore, there are more settling of organic materials in the ocean. So that is one of the strategy for climate change mitigation. During 2008, there is an event called Kasatochi volcanic eruption at Aleutian Island. Based on the article by Langman et al. 2010, the satellite data provided has shown that volcanic ash fall caused a large-scale phytoplankton bloom in an iron-limited oceanic area. So they are estimated to have removed 10 million tons of carbon from the sunlit zone during that time. So we move to ocean ion fertilization experiments. There are two types of ocean ion fertilization, which is natural ocean ion fertilization experiment and artificial ocean ion fertilization experiment. So the total of natural ocean ion fertilization experiment is 6, while for artificial ocean ion fertilization experiment is 13. There were 12 experiments conducted at HNLC regions, while 1 experiment conducted at LNLC regions. So what are the limitations during ocean ion fertilization experiment? First is single ion addition, micro and macronutrients limitation, insufficient experimental duration, like limitation caused by storms, no export flux measurements, high dilution rate by small patch size, and entrainment of dissolved silicates. In my opinion, the experiment conducted are not fully success. They need to improvise some details or some limitation to get a better result in the future. So based on the artificial ocean ion fertilization experiment, they are successful in led to increase of primary production, such as the changes of the size of phytoplankton community. For example, from the sizing of picophytoplankton, they move to nanophytoplankton and microphytoplanktons. So the dominant species during that time is diatoms. In the terms of carbon sequestration success, IFEX is the only experiment that shows significant results in exported carbon to the deeper layers of the ocean up to 3,000 meters below. So there are a lot of improvement that can we do for future ocean ion fertilization experiments, such as estimate the duration of experiments accurately in order to give enough time for response of the ion addition. Then choose appropriate experimental sites, such as experiments should be conducted in areas with sufficient nutrients and less limitations. Next, strategic approach to addition of ions. From the article, they need to have an interval of 10 to 15 days to prevent ion limitation. Next, suitable timing to conduct experiment. Consider climate and weather condition to get a better results in the future. Last but not least, monitoring the amount of ion added to minimize bad side effect towards marine organisms and humans. This is the references used by me, and I hope the explanation that I give are clear and you guys can understand it very well. That's all from me. Thank you very much. See you soon.